Hello. Earlier we have seen an introduction to K-Medoids clustering. Now we explain it with an example and also the algorithm. So this is a recap where we had taken two cases of the same set of data points. Once choosing m equal to 3, 2, this is the Medoid, and once choosing m equal to 2, 1, and then computing the error basis this formula which we want to minimize. We decide that this is a better choice because the error for m equal to 3, 2 comes out to be 9, while that for m equal to 2, 1 comes out to be 11. Now we write down the steps of the clustering algorithm, which is called partitioning around Medoids, PAM. So here we have k clusters to be made. K is a user provided input. So we choose k objects in D as the initial representative objects or seeds, assign each remaining object to the cluster with the nearest representative object. So this is the initial clustering, and then we have this iteration. Select a non-representative object m random, compute the cost of swapping this an existing representative object m with m random, and if this cost, the new cost minus the old cost, so if the cost is getting reduced, you perform the swap, and this iteration continues until there is no more change. Okay, so we have this example with 10 data points, and we initially choose m1 as the f point, which is this point f, and m2 is j. m2 is j. Okay, these two we have chosen. We then compute the distances of all the data points with the representative objects m1 and m2. These are Manhattan distances, and distance computation, I will provide a link in the description box to the previous videos. So based on the shorter distance, we see A gets assigned to m1. Similarly, B gets assigned to m1, C gets assigned to m1, D, E, F, and G. At G and H we have a tie, so we decide to put G in m1 and H in m2. So we have cluster 1 with A, B, C, D, E, F, G, and cluster 2 as H, I, G. So these are two clusters, and we compute the errors. Error for the first cluster is basically the sum of the distances from the mean, and error for the second cluster is again this distances from the mean, so it is 24. So in the first initial taking the seeds, choosing the seeds arbitrarily, m1 equal to f and m2 equal to j, we see that we get two clusters, one with 7 points, one with 3 points, and the error is 24. So after the first iteration, we choose a non-representative object C, and we consider replacing it as the new Medoid for cluster 1. So we want that M1 should be swapped and made C instead of the previous choice of F. So we again assign data points and compute the new cost. So for assigning the data points, M1 is now C and M2 remains F as it is previously. We compute the distances, and now here we see that A, B, C, D, E, F clearly go to cluster 1, while G now goes to cluster 2. See, it has changed the assignment. The assignment of G gets changed to cluster 2. So 6 points in cluster 1 and 4 points in cluster 2, and the new cost comes to 20. The sum of these costs from cluster 1 from A to F and from G to J for cluster 2 comes to 20. So this is the new clustering, 6 points and 4 points, and since the difference of cluster cost, new cost is 20, previous was 24, so there is a reduction in cost, so we can perform the swap, and new Medoids are now C and J. So this completes the one iteration of the choosing a new non-representative object and considering it for swapping, and in this case we saw that the swap could be performed because the cost was actually getting reduced. We shall go through more such examples and more details in the next videos. Thanks for watching.